This is a pre-calculus worksheet on a bunch of different things. I guess the L'Hopital's rule. That's how to pronounce it, kind of. You can either spell it Hopital, and usually they put a little mark over the O. I don't know what it's called, a little boop. I call it a boop, whatever it is. Or you can put an S in there in the English spelling, Hospital, but it's pronounced L'Hopital. L'Hopital, like A as an an. L'Hopital, something like that. Okay, it can be applied to which of the following? Well, it can be applied when you work the limit, if it's 0 over 0, or infinity over infinity, or negative infinity over negative infinity. That's C. I have to work 1 through 6, and then 9, 11, 13. So I'll do 1 through 6 in this video, and then I'll do the other ones in the next one. This is a limit as x goes to infinity of this function. Well, for practical purposes, this is if the degree of the top and the degree of the bottom are the same, in this case the highest power is squared, then just take the numbers in front of them, 3 over 4. So the answer to this one is 3 over 4. So that's C. This one, 1 to the 11th, 1 to any power is 1. 1 to the 11th is 1 minus 1 is 0. 3 times 1 to the 4th is 3 minus 3 is 0. That's an indeterminate form. So I can apply L'Hopital's rule. And that says I have to take the derivative of the top and the bottom. Derivative of the top is 11x to the 10th power. Derivative of the bottom is 12x to the 3rd power. And then try applying the limit. This is limit as x goes to 1. 11 times 1 to the 10th is 11. 12 times 1 to the 3rd is 12. The limit is 11 twelfths. Number 4, where a and b are constants with a not equal to 0 and b not equal to 0. I think I got this one wrong earlier today, which is why I'm redoing 1 through 4 in this video. It's x to the a minus 1. So let me see, as x goes to 1. 1 to the a, 1 to any power is 1, minus 1 is 0, over 1 to some power, where it's, even if it was, this I don't get why a is 0 and b is 0, because 1, if x is approaching 1, 1 to the 0 power is still 1. So, but anyway, 1 to any power is 1, minus 1 is 0. Indeterminate form. So now I will take the derivative of the top, derivative of the bottom, and then reapply the limit. Derivative of x to the a minus 1 is a times x to the a minus 1. I multiply by the exponent and then subtract 1 from the exponent. And likewise, b is x to the b is going to be b times x to the b minus 1. Well, that's one of the answers. Isn't that it? No, because I have to take the limit as x approaches 1. This is what I picked before. It's wrong. This is a times 1. 1 to the a minus 1 power divided by b times 1 to the b minus 1 power. Well, 1 to any power is 1. So a times 1 is a. B times 1 is b, so the answer is a over b. This is an interim answer, but not the final answer. Number 5, this says x approaches 1. So I will try to plug 1 in and see if it comes out to a number or an indeterminate form. Then I can apply L'Hopital. 3 times 1 cubed is 3, minus 4 times 1 squared is minus 4, plus 1. 3 minus 4 is minus 1, plus 1 is 0. This is 9 times 1 cubed is 9, minus 2 times 1 squared is minus 2. That's 7 so far. Minus 6 times 1 is 6. 7 minus 6 is 1. 0 over 1 is 0. So the answer is 0. If it were the limit as x approaches infinity, and I notice there's an x cubed and an x cubed on top and on bottom, I would just take the coefficients in front of x cubed. That would be equal to 3/9, which would be 1/3. But it's not asking for the limit as x approaches infinity. It's asking for the limit as x approaches 1. So it's 0. Let's try the next one. Determine the value of limit x approaches infinity of cosine x over x, if it exists. Well, remember, cosine fluctuates between -1 and 1. And then there's x, and I'm going to plug in infinity for x. So cosine of infinity is not infinity. It fluctuates between -1 and 1. You have to use something here called the squeeze theorem. Find the limit at the lower bound, which is -1. Find the limit at the upper bound, 1. And the limit of the actual function will be in between there. So at the lower bound, it's -1 over infinity. Well, that's 0. At the upper bound, it's 1 over infinity. That's 0. So the actual limit will be somewhere between 0 and 0. Any number over infinity is 0. So somewhere between 0 and 0. So that means the limit is 0. And that's answer A. That's it for this 1 through 6. Next video will be 9, 11, 13, I think.